In the far reaches of our solar system, Neptune, a world of deep blue mystery, awaits. It's the last of the great planets, orbiting so far from the Sun that daylight is nearly 1,000 times dimmer than on Earth. For centuries, Neptune was just a faint speck in our telescopes. Even Voyager 2's 1989 flyby gave us only a brief glimpse, a vibrant blue orb with the fastest winds in the solar system. But Neptune's secrets remained hidden until now. The James Webb Space Telescope has turned its powerful gaze inward, revealing Neptune as never before. Webb's infrared vision is peeling back the layers, showing us a world far more dynamic and strange than we ever imagined. The quiet frozen giant is finally beginning to speak. New images and data are challenging everything we thought we knew about Neptune. We're seeing dramatic changes and unexpected phenomena that force us to rethink the ice giants. Today, we stand at a new threshold of discovery. Guided by Webb's infrared light, we'll explore shocking new findings and try to understand a world whose atmosphere defies explanation. Let's begin this journey. Let's go to Neptune. We know the auroras on Earth, dancing lights near the poles created by the Sun's particles and our magnetic field. Jupiter and Saturn have their own spectacular auroras, so scientists expected Neptune to have them too. But for decades, Neptune's auroras remained elusive, hidden by distance and atmospheric haze. Voyager 2 caught only a faint hint in 1989, and even Hubble couldn't see them clearly. The question lingered: where were Neptune's auroras? In June 2023, Webb's infrared eyes finally pierced the gloom. For the first time, we saw direct, unmistakable images of auroral activity on Neptune. The ghost lights had finally been captured, a triumph of technology and persistence. But the discovery led to a new mystery. The lights weren't where we expected. Neptune's auroras were in the wrong place. On Earth, auroras crown the poles, mapping where our magnetic field meets the atmosphere. Jupiter and Saturn follow the same pattern. But Webb's images showed Neptune's auroras shimmering at mid-latitudes, not the poles. Imagine seeing the northern lights over North Africa instead of the Arctic. That's how strange this is. This unexpected placement revealed that Neptune's magnetic field is unlike any other in the solar system. The auroras are a glowing clue, pointing to a bizarre magnetic engine deep inside Neptune. Why are the lights so far from the poles? The answer lies in the planet's magnetic field, a field that breaks all the rules. To understand these misplaced auroras, we must look beneath Neptune's clouds. The lights are just the beginning of a much stranger story. Let's dive deeper. Neptune's magnetic field is wildly tilted, by 47 degrees from its spin axis. Unlike Earth's steady field, Neptune's is lopsided and unstable. Its magnetic poles wander across the planet as it rotates, creating a chaotic multipolar field. This field is likely generated in a slushy layer of water, ammonia and methane ice, not deep in the core. The result? Solar particles follow twisted magnetic lines, lighting up the atmosphere far from the poles. That's why Neptune's auroras appear at mid-latitudes. These lights are a visible map of the planet's internal weirdness. By tracking how the auroras shift, scientists can study Neptune's magnetic field from afar. The auroras are more than a light show, they're a window into the heart of an ice giant. Neptune continues to defy expectations at every turn. Each new discovery brings us closer to understanding its strange interior. The mystery of Neptune's magnetism is just beginning to unfold, and the surprises keep coming. Webb found something else astonishing, a dramatic drop in Neptune's upper atmospheric temperature. Voyager 2's 1989 measurements gave us a baseline, but Webb's 2023 data showed the stratosphere had cooled by hundreds of degrees. This massive change was completely unexpected. The cooling may explain why Neptune's auroras were so faint for decades. Colder temperatures dimmed the lights beyond our telescope's reach. Only Webb's sensitivity could reveal the faint glow that remained. But why did Neptune cool so much? Is it a strange seasonal effect or linked to the Sun's activity cycle? We don't know yet, but one thing is clear. Neptune is not a static world. It's dynamic, capable of massive shifts within a single human lifetime. The ice giant is full of surprises. To confirm the auroras, scientists needed more than images. They needed a chemical fingerprint. Webb's NIRSPEC instrument split Neptune's light into a spectrum, searching for a telltale marker, the trihydrogen cation H3+. This molecule glows in auroral regions on Jupiter and Saturn, serving as the gold standard for confirmation. Webb detected a strong H3+ emission from Neptune's upper atmosphere, exactly where the auroras appeared. This was the smoking gun, undeniable proof of auroral activity. The combination of images and spectral data created an ironclad case. To visualize the discovery, scientists combined Webb's infrared data with Hubble's visible light images. Neptune's familiar blue orb now glows with ghostly cyan patches, auroras shining in the southern hemisphere. These composite images revealed the precise location of Neptune's strange, misplaced lights. Webb didn't just see the auroras, it analyzed their chemistry from nearly 3 billion miles away. The discovery is a triumph of modern astronomy. Neptune's secrets are finally coming to light. Neptune's new revelations are rewriting what we know about ice giants, planets unlike any others in our solar system. For decades, our knowledge came from a single Voyager 2 flyby. Now, Webb's discoveries show these worlds are active and changing, not static. The dramatic cooling and bizarre auroras reveal complex processes at work. Studying Neptune's magnetic field and auroras gives us a natural lab for understanding planetary magnetospheres under extreme conditions. These findings help us build better models for Uranus and for the countless Neptune-sized exoplanets across the galaxy. In May 2025, Webb even detected water vapor on a distant sub-Neptune exoplanet. By revealing Neptune's secrets, Webb is providing the key to understanding thousands of similar worlds. The ice giants are no longer mysteries. They're the foundation for exploring the universe. Our place in the cosmos is clearer than ever, and the story is just beginning. Webb's discoveries have launched a new era of Neptune exploration. We've moved from a single snapshot to a dynamic unfolding story. Scientists are eager to keep watching Neptune, tracking its auroras and temperature over years, even decades. Observing Neptune through a full solar cycle will reveal how the planet responds to changes in the Sun's activity. Will the auroras brighten? Will the atmosphere warm or cool? These questions will fill major gaps in our understanding of planetary atmospheres. Webb's infrared vision is now essential for future missions to Uranus and Neptune. The path forward is clear. We know what to look for and how to look for it. Webb isn't just answering questions, it's showing us what to ask next. We live in a remarkable time, when distant worlds reveal their secrets in new light. With tools like Webb and our own curiosity, we can keep reaching out, learning and understanding. The story of Neptune is still being written, with many more surprises ahead. The journey continues.